Okay, can I write anything here? Probably not. So the first question is saying A is given, find A square and A cube. So you really have to do math. One idea of what they're going to be what you're not going to square each element. Did you square each element? A square, can I write? Oh, I can do annotation here. Okay, so A square means A times A. So you're going to multiply 1/2, -1/2, -1/2 here. And then you do the regular multiplication. You take one row, one column. So you multiply, you really multiply them, not squaring them. Oh wow, my green looks very weird. Let me change the color. Red. So A times A. And you take first row on the left and then each column on the right. So you get 4 elements. Quarter for each element. Let's see. 1/2 times 1/2 is 1/4. Minus 1/2 times -1/2 is positive 1/4. Right? -1/2 times -1/2 is 1/4. So 1/4 plus 1/4 is 2/4. 2/4 is 1/2. Not quarter. Eraser. So let me erase it. Let me write nicely. So you take 1/2. Where is my thing? You're not squaring them, you're multiplying them. So you take 1/2. How do we go back to my ink? Oh, here. So you have 1/2 times 1/2, which is 1/4. And then you're adding -1/2 times -1/2, which is positive 1/4. So it is 1/4 plus 1/4, 2/4. But the 2/4 becomes 1/2. So this is the first element. And then you go to the second one. 1/2 times -1/2 is -1/4. So 1/2 times -1/2 is -1/4. And you are adding -1/2 times positive 1/2, which is -1/4. Right? -1/2 positive 1/2 is -1/4. So you get -2/4, which is -1/2. And then you go the other way. You take the next one and you multiply the first row, second row, first column. So 1/2 times 1/2 is -1/4. 1/2 times -1/2 is -1/4, which is -1/2. And then you do the other one. -1/2 is positive 1/4. And you're adding -1/2 times positive 1/2, which is positive 1/4, which is 2/4 means 1/2. So you have 1/2, -1/2, -1/2, positive 1/2. This is your A square. And if you observe, let me use anything. If you observe, this is actually same as your A, right? 1/2, -1/2, -1/2, positive 1/2. So A square is same as A. Now, if you want to find a cube, it means you take this A square and you multiply by A. Basically, you take your A and then multiply here. But you already did that. We already multiplied A with A and we found the same matrix. So can you guess what would be A cube? It's the same matrix. It's A. Now the third one is asking Well, what do you think about any power on A? A4, A5, A100, A1000, for any power of A, what would be the product? What would be the final result? You see? This is what the observation is. First compute two of them, and based on that, figure out what will be the result for any power. So this is what we are doing in the first one. Second one says you have a square matrix. An n by n matrix is said to be an involution if a square is I. So if you multiply, if you take square of a matrix and you get the identity matrix, then we call that involution matrix. And it says we are giving a matrix so that using an involution matrix. It means multiply G with G. Multiply G with G and see if you get identity. If you get identity, that means yes, it is. Now, what type of identity matrix you're going to have here? 2 by 2 or 3 by 3? Good, 2 by 2. So you're going to have an I2. How do you write the identity matrix for 2 by 2? 1, 0, 0, 1. So here you're verifying. If you multiply G with G, do you get 1, 0, 0, 1? This is what they're asking you to do. And then actually use everything to go to the next window. Yeah, all right. The next one is saying a matrix is said to be idempotent or idempotent if A square is A. So if A square is A, they have a special name, idempotent. And now it says show all of these are idempotent. Means multiply this by same thing, 1, 0, 1, 0, and show that this is 1, 0, 1, 0. Okay. So multiply, show that the result is the same matrix. Same thing here, you're going to multiply 2/3, 1/3, 2/3, 1/3. And if you multiply, the result will be 2/3, 1/3, 2/3, 1/3. And then you're going to do by 3 by 3. So basically saying if you multiply the same matrix twice, you get the same matrix back. Just like the one we did before. But that one was special. If you multiply, well, yeah, that isn't the same thing, I think. If you multiply, it doesn't matter how many times, you get the same thing back. Now the last one says, show that A transpose A and A transpose, they both are symmetric. You can take any general matrix, A11, A12, A21, A22. So let's say this is your A matrix. I'm not using any number because if you use any number, then you're not proving anything. You're just giving me an example. It says show that means prove that they are symmetric. So you cannot use any number. You can use variable. So here I use small a for my variable for my length, and 1 means first row first column. 1 2 means first row second column. 2 1 means second row first column. 2 2 means second row second column. So yeah, I'm using the smallest one, 2 by 2. You can use any size. It didn't say what size. So you can use, oh, it says M by N. So I had to change my size. So let's say 1, 3, and 1, 2, 3. So they are not telling us to use square matrix. They're saying use non-square matrix. So I have 2 or 3 columns. It's a non-square matrix. Now, if you look at its transpose, A transpose. what would be its transpose? Or maybe I can use A, B, C, D, E. It will be easier for you. So let's say I have a matrix. A, B, C, D, E, F. Then what would be its transpose? You are writing ABC here, written as row wise. You have to write column wise. So it would be A, B, C, D, E, F. This is the transpose. Okay. Now it says, so this is 2 by 3 and this is 3 by 2. They are saying that if you multiply them, your result will be a square matrix. Show that. So all you have to do is multiply A times A transpose. So A, B, C, D, E, F. You're multiplying A, B, C, D, E, F. And then you're writing the product here. The product will be, so this is 2 by 3 and this is 3 by 2. So what will be the dimension of the product? Good job. You know your math. 2 by 2. And then you do the other way around. You do A transpose. A transpose. Okay. So A transpose is A, B, C, D, E, F. So now A is A, B, C, D, E, F, row wise. So now this is 3 by 2 and this is 2 by 3. So what would be the dimension for the result? 3 by 3. So you don't have to do the math. You can simply show the proof with your letters A, B, C, D, E, F. That's the way to do here. Nothing hard, nothing fancy. Any question? Okay then. Now let me tell you what will be in the exam. Clear all times. So I posted the review sheet on Brightspace. Oh, let me show. I should go to Brightspace. Let's go to your class. Your class is section 6. Under homework tab. So I already posted the solution for 1.1, 1.2, and 1.2 part 2. So the first 3 homework you already submitted. I posted the solution. Now you have to do homework 4, which is 1.3, and homework 5, which is 1.4. Now for 1.3, that deadline I said tonight midnight, but I noticed most of you did not submit anything yet. So I'm going to extend that till Wednesday midnight. That means for Wednesday, you have 2 sets of homework if you haven't submitted your homework yet. So by Wednesday midnight, before Wednesday midnight, you're going to submit homework number 4 and homework number 5. And then you have very important homework, that's the review sheet homework. Review sheet homework or 60 points. So it's a huge assignment, okay? All the other homework, they are either 6 points, 17 points, 13 points, like those, depending on how many questions you have. But here the review sheet is of 60 points. And the review sheet homework I'm going to check based on correctness. The other homework, they are based on completeness, and I check only one question for everyone. If you have that question correct, then you get full point. If you get that question wrong, then I'm going to take off points. But for the review sheet, it's based on completeness plus correctness. How many you get correct? How many you completed? Based on that, you have your review sheet homework and it's due before Saturday midnight. And I'm not going to extend that because after the midnight, I'm going to put the solution. So you have Sunday to study for the exam. And then your exam will be Monday. Okay? So this week, 3 sets of homework. Wednesday, 2 sets. If you haven't submitted your 1.3 yet, if you did, that means you have only 2 more homework to do. And actually, it is a few of you submitted both of them. I was very glad. Like, oh, you submitted both homework. That means it is a free. You have only 1 homework to do. And that homework the exam will be very similar to that review sheet homework. Oh, also one more thing. Either to submit your solution, you can click here under the homework tab, or if you want, you can simply go to the homework tab here and then submit. They both are same. You can submit one, and you can submit only once. One PDF file, one submission. Okay? So do them correctly, neatly, so that I can see what's going on, what you did, and try to explain everything with as details as possible. Okay? Any questions? Okay, so then we have this. So I'm going to give, in the exam, I'm going to ask you true, false, fill in the blank, multiple choice question probably. Probably it will be 10 points, something like that. And those questions will be from your lecture notes. So if you haven't noticed that yet, I actually posted all the lecture notes under pre-lecture notes. The first one is from 1.1 to 1.4, and your exam will be based on that. So if you want to read the lectures, whatever we did in class, you can simply go over that notes. That doesn't have any solution, okay? It's just pre-lecture notes without anything written on there, any solution written on there. So I'm going to ask you questions from the lecture notes, and then I'll ask a few of these. Find out which one is in row echelon form, which one is in reduced row echelon form, and which one is in neither form with you. At least 3. And there could be more than 3. Then the next one is saying that all the information is given. Based on the information, you have to figure out what type of solution you have. Do you have a unique solution? If you do, what's the value for them? What's the x1, y1, x1, x2, x3, x4? What's the value for each of them? And then, or do you have infinite solution? If you have infinite solution, that means you have to write the equation for each variable. Which one is free variable? And the other variable, how it's depend on the free one. For example, let me give one example. Which one has infinite solution? This one has infinite solution. So how do you know? If you don't know, no problem. You're going to figure out purple. So you start from here. So this is, you can use xy, y1, x1, x2, x3, or you can use xyz. If you use xyz, that means this is telling us that our z is 3, right? And then this one is telling us x minus 2y plus 4z is 1, right? This is what is given here. But you already know our z is 3. That means this is 12. So you add this and subtract that. So subtract 12 from both sides, and you add 2y to both sides. So they cancel out. You have x is 2y minus 11. So your x is 2y minus 11. Your z is 3. But then what is y? Do you have any information about y? No. That means your y is a free variable here. So your y is y. This is what I meant you should do here. If it's infinite solution, find out the other variables in terms of the free variable. If it's unique solution, for example, which one has a unique solution? One of them has a unique solution, okay? So you don't see the unique solution here, but once you do some modification, once you do backward substitution, you will see unique solution. For example, here, this is telling us our z is 2. This one is telling us y plus z is 7. That means you can solve for y. And this one is telling us we have x minus y plus 3z is 8. You know your y, you know your z, so you know what is your x. So find out what's the value for x, y, z. So if you have a unique solution, you have x, y, z as a number. If you have infinite solution, you don't have them as a number, you have them as a variable. And if you have no solution, it means no solution. So which of these doesn't have a solution? At least one. Mention at least one. Which one doesn't have any solution? How do you know? Do you remember? The bottom row. So which one? E? Definitely. It's saying that variables x plus y plus z equals no variables equals 1. It doesn't make sense. No variables equals 1. No variable should be nothing, not 1. So this is telling us we have no solution. So if you have no solution, just write no solution. But for other two cases, you must do some math. And I'm going to give you at least 3 because you have 3 scenarios. Yeah, no solution. Now, next one, we have one of them no solution, one of them unique solution, one of them unique infinite solution. And the fourth one, figure out which one is that. Okay. So in the exam, I'm going to give only one because you cannot do more than one in that short amount of time. So definitely one, and I'm going to do 3 by 3. So this is 3 by 3. This is 4 by 3. This is 3 by 3. This is 3 by 4. So I'm going to, my plan is to give one, definitely not 2 by 2, 3 by 3. So you have a good way of solving them. Do you remember which 3 operations are allowed in row echelon in elimination process? 3 rules. One of them is swapping. You're allowed to swap any 2 rows. What's the other allowed operation? You can do multiply by a constant and then addition subtraction. And what's the third one? It's in the second one. You're allowed to multiply by a non-zero constant. So you can swap 2 rows, you can multiply the entire row by a non-zero constant, and then you can multiply a row by a constant and then add or subtract with the other row. So addition, subtraction is allowed, multiplication by a constant is allowed, and swapping is allowed. These are the three operations you're allowed to use to use elimination process. The next one says, by observing their dimension, figure out which multiplication is allowed. If it's allowed, multiply them. And also, before multiplying, tell them what's the dimension of the product matrix. So, three things you're going to do here. One, figure out if it's multiplicable or not. If it's multiplicable, then what's the dimension for the product? And then find the product. So in the exam, I'm going to give you a few of these for part 1 and 2. And for the multiplication, you're going to do other questions. For example, here, on question number 6, you're going to multiply them. Question number 5 has 2 parts. It says, first, you're going to write them in equation form, ax equals b. For example, this is short one. Let's do this one. You need to find the coefficient matrix, the variable matrix, and then the constant matrix. So what would be the coefficient matrix for this system of equations? 1, -2, and then -4, 5, -6. So this is our A matrix. And now for X matrix, column-wise or row-wise? Column-wise, X, Y, Z. And then lastly, our B matrix. Column-wise or row-wise? Column-wise. So, the B matrix and the X matrix will always be column matrices. A will have different shape, different dimension. So this is step 1. Convert them into matrix equation. And then the second process, figure out for this A, can you find A inverse? Means, does inverse exist for this matrix? Do you remember what's the requirement to have an inverse? There is one requirement. Good job. A has to be square. So only square matrices can have inverse. So can you have inverse for this A matrix? No. Why not? Because it's not square. So this is 1, and for 2, no. And you write because it's not square. Square. That's what to do. No math is needed. Convert and then figure out whether we can find inverse or not. 6, even though I gave you 3 of them, but you have to do math for only 1 of them actually. The other 2 are tricks. If you know your tricks, you don't have to do any math. But if you don't know the trick, then you have to do the math. Okay? This is the multiplication. So try to figure out what tricks you have there. And if you do multiply, you have to do 1 by 1. For example, we have F25 A inverse, so not inverse. Transpose, subtract the C matrix, and then whatever you have for the result, and then to multiply B on the right side. Okay? So I'm going to give at least 1 in the exam. The next one is just like the homework. Find out how to find the square. So maybe I can, actually too much. I'll give 1 for 7 and 1 from 6. In 6, it says find the square for A. Then subtract the B matrix from the result. And then add the transpose of the C matrix with that. So you're going to do 3 operations and then combine the results. Question number 8 is for fun. So, fun. I'm not going to put it in the exam. It's for fun. But it's an interesting proof. So if you going to do the proof, then you have to prove two things. First thing is prove that if A and B are non-singular, so this is part one. If A and B is non-singular, then their product has to be non-singular. Means if A and B, they have inverse, then their product has to have an inverse. And then you're going to prove that the inverse of the product is the product of the inverse, but in the reverse direction. So this is part two. This proof has two parts. And then I want to post the solution later, after the deadline. So you'll see how we should do. But one hint here is that in our last lecture, I mentioned that if you multiply A with its inverse, you get identity matrix. It doesn't matter which way you multiply. You can multiply on the left side or you can multiply on the right side, but the multiplication, the product, has to be inverse. So you can use that fact to do part two. Okay? And you can go both ways. You can go one way. You can go from left to the right side, or you can go from right side to the left side. Or you can do both of them at the same time. Yeah. So play with that. See how can you prove that. Good news, it's in the book. So you might see the solution in the book. Then question number 9 says, just tell me what are the identity matrix for 2 by 2, 3 by 3, and 4 by 4 matrix. So basically you're finding I2, I3, and I4. The purpose of this question is to show you how the identity matrix look like. Even though I showed you many times, but you may have forgotten them. So if you do them by yourself, you'll have a sense of knowing how the identity matrix look like. The last one is a fun one. We are going to do two examples similar to that, and then you will see how to do this. I'll give either both of them or one of them. Okay? You didn't do any math. Let me show you how to do that using this graph. So the purpose of this is to show you that what type of matrix is symmetric matrix. So a symmetric matrix is those matrix if its transpose is the same as the original one. So if A transpose equals A, then A is a symmetric matrix. So one of the examples for the symmetric matrix is this adjacency matrix. The adjacency matrix, we get them from reading a graph. So it's like network. You have 5 network, 1, 2, 3, 4, 5, and we tell computer how the network is working. For example, here, from V1, you can go to network V2, 3, 4, and 5. So we write them like this. Let me do it here. What is something? V1, V2, V3, V4, V5. And then you go one by one. From V1, you're going to V1. From V1, you cannot go to V1 because there is no network, there is no path from V1 to V1. So V1 to V1, there is no path. We indicate that with 0. There is no path to go from V1 to V1. However, from V1, you can go to V2, 3, 4, and 5. And you can go only one way. There's only one path from V1 to V2, 3, 4, and 5. So from V1 to V2, you go one way, one way, one way, one way. There is one path from V1 to everything else. Then you go to V2. and you see how many paths you have, or whether you have a path. So our V2 is here. We cannot go from V2 to V2, so V2 to V2 is 0. But V2, you can go to V1. If you go to V3, you can go to V4, and you can go to V5. So from V2, you can go everywhere else besides itself. So 1, 1, 1, 1. And then you do V3. So V3 is here. From V3, you can go to V1, you can go to V2, you can go to V4 and V5, but you cannot go to V2 to V2, there is no path. So 1, 1, 0, 1, 1. And you keep doing that, and then at the end, you'll see that this is actually symmetric matrix. All the rows and columns, they are same. However, not every adjacency matrix will give you symmetric matrix. For example, this question. We have this. So let's say this is A, this is B, this is C, and this is D. Now, let's say we have this. And also we have this. The difference between this graph and the previous graph is that in the previous graph we have two ways direction, so we did not use any direction. Here our direction is one way mostly. So this is called a directed graph. Directed graph, and this is not directed graph. The not directed graph has two-way connection. The directed graph, it has one-way connection. Only based on the direction when you have your results. So we have A, B, C, D, 4 network, and you're going to go there one by one. Now this time, from A to A, can you go from A to A? We can, if you start your journey from here, you see, events at A. So there is a loop from A to A. So now you have a path from A to A. It's possible. One way you can go A to A, following that loop. Now from A to B, how many ways can you go A to B? How many ways? This is the direct path, and this is indirect path. It's kind of curved path. But how many ways you can go from A to B? 2 ways. So from A to B, there are 2 paths. Now from A to C, can you go from A to C? How about A to D? There is no connection from A to C or D. So these are 0. Then we go and look at B. From B to A. B to A. Can you go from B to A? Yes, because there's a direction here. From B to A. So B to A is 1. How about B to B? No, because there is a loop this time. It's just B. You cannot start your journey and come back at B like A. It's not possible. So B to B, there is no path. How about B to C? How many paths? 1. There's one direction, so it's 1. And how about B to D? No, you cannot, because there is no connection from B to D. And then you go to C. This is your C. From C, can you go A? Can you go B? Can you go C itself? Can you go D? So 0, 0, 0, and then yes. And now lastly, from D. This is your D. From D, can you go A? Can you go B? Can you go C? Can you go D? So for D, nothing is possible. So D is the most lonely one. And then you go use 2 bar to make 2 square matrix, 2 square parentheses, 2 square brackets. for the matrix. Now, is adjacency matrix symmetric? How about this one? Is it symmetric? No, because our row and column, they are not same. So it's not a symmetric matrix. So this is what you're going to do in the exam. Convert your graph into adjacency matrix and then tell me adjacency or then asymmetric. Any question? So that's all I have for today, actually. Unless you have any other question. Do you have any question from the review sheet at all? No. So I already mentioned what will be in the exam. 1 or 2, 10, 9 you're going to use in different cases, I think. Definitely 1. And then there will be a few of these. A few 1 and 2. For that, I'll ask it inside question number 5 or question number 6. Well, question number 5 doesn't have to do any math, sorry. So a few these, question number 6 or 7. Only 1 row echelon form, reduced echelon form, at least 3 of solutions, and at least 3 of row echelon, reduced echelon, or not reduced at all. I didn't make the exam yet. Based on the review sheet, you'll have at least 8. Because I have at least 8 questions here. So 10 questions. So at least 10. But I'm not going to ask the proof question. Proof 1 and the identity. Identity, I'm not going to ask explicitly. I'm going to just use it somewhere probably. Okay, so as long as the bottom line, as long as you do the review sheet very well, correctly, you're ready for the exam. And the review sheet due date, when is the review sheet due date? Saturday before midnight. There will be no extension. Okay? And the link to submission will be disappeared after midnight. So make sure you submit before midnight, not 12 a.m., before 11:59 p.m. Okay? That's all for today. Thank you for being here. I didn't take the attendance today. I'm going to take it in next class. So good luck. Don't forget to submit all the homework